Welcome. Today, we're diving into the world of Kotlin Flow, a tool familiar to most Android developers. If you've ever returned StateFlow or SharedFlow from a ViewModel and collected them in your UI, you know how smooth things can be. But what happens when things aren't so straightforward? In this video, we'll explore the limitations of Flow, especially when values are produced outside the usual context. We'll also see why channel flow and callback flow exist and how they solve real-world problems. Let's set the stage for a deeper understanding of these essential tools. Many Android developers using Flow is second nature. You might return a StateFlow or SharedFlow from your ViewModel and collect it in your UI layer. Libraries like Room and Retrofit make it even easier by exposing Flow directly. This setup keeps things simple and predictable, letting you focus on building features rather than managing data streams. But as you'll see, this familiar pattern has its boundaries, especially when you step outside the comfort zone of direct, in-context emission. While Flow works beautifully in many cases, it has a significant limitation. Problems arise when values are produced outside the context where the flow is collected. This can happen with callback-based APIs, legacy components, or work started in GlobalScope. In these scenarios, emissions don't happen in the same coroutine, and the usual flow mental model breaks down. Even if your code looks correct, a regular flow builder can't handle these emissions safely. You might wonder why this limitation is important. In real-world Android development, it's common to interact with external sources, like callbacks, legacy code, or libraries that don't use coroutines. When values are produced outside the collecting coroutine, Flow's safety guarantees no longer hold. This can lead to unexpected errors, unsafe UI updates, or even crashes. Understanding this limitation is crucial for building robust, maintainable apps. Let's look at a simplified example to illustrate the problem. Imagine you want to prepare several values in parallel and emit them to a collector. The code compiles without warnings and seems like a neat optimization. You launch 3 coroutines, each emitting a value after a short delay. The expectation is that all 3 run in parallel, finishing quickly. But when you run this code, you get a surprising error. Here, what happens? Flow throws an IllegalStateException, stating that emission from another coroutine is detected. This is because FlowCollector isn't thread-safe, and concurrent emissions are strictly prohibited. The coroutine logic is valid, but Flow enforces a rule: emit must be called from the same coroutine that runs the collection chain. Violating this rule stops execution and highlights Flow's core limitation. Why is Flow so strict about where emit is called? The answer lies in how Flow connects the producer and collector. With a regular Flow builder, both the producer and collector run in the same coroutine. This design keeps things simple and predictable, but it also means that emissions from other coroutines break the model. Flow never starts new coroutines on its own, so it expects all emissions to come from the collecting coroutine. Understand Flow's behavior. Let's build a minimal mental model. When you call collect on a flow, the flow block runs in the same coroutine. Each emit immediately invokes the collector block. There are no extra coroutines involved unless you explicitly change the context. This model works well for simple streams but falls short when emissions come from outside the collecting coroutine. Let's revisit the earlier example. The collector calls collect, and Flow runs the flow block in the same coroutine. Each emit immediately triggers the collector. This synchronous execution keeps things straightforward. However, if you try to emit from another coroutine, Flow detects the violation and throws an error. This is why parallel emissions using launch blocks don't work as expected. The failure isn't due to parallel work itself, but rather the coroutine from which emit is called. Each launch creates a new coroutine, and calling emit from these violates Flow's core rule. The collector block is meant to run in the collecting coroutine, but now values arrive from different coroutines. This can lead to unsafe access to shared resources and inconsistent state. The collector often relies on running in a specific context. For example, in Android, you might collect a flow in ViewModel and update the UI. If emit is called from another coroutine, possibly on a different dispatcher, the collector block runs there too. This breaks the expected context, making UI operations unsafe and potentially causing crashes. Flow enforces its emission rule strictly. If a value is emitted from a coroutine that isn't the one driving the collection chain, Flow throws an exception. This prevents hard-to-debug issues and keeps your code safe. However, it also means you need another approach when dealing with external or uncontrolled sources. This limitation isn't just theoretical. In real applications, you often deal with callback-based APIs, legacy code, or libraries that don't use coroutines. These components might deliver results through listeners, start work in GlobalScope, or use threads outside structured concurrency. In all these cases, values arrive from outside the collecting coroutine, and regular Flow can't handle them safely. To work reliably with Flow in these scenarios, you need a mechanism that can accept values from external or uncontrolled execution contexts. This mechanism should forward values to the collector without breaking Flow's rules. That's where channel flow and callback flow come in. They bridge the gap between external sources and Flow's strict execution model. Channel flow is designed to handle values from multiple coroutines or external sources. It creates a channel that acts as a buffer, allowing emissions from different contexts. The channel ensures that values are delivered to the collector safely, maintaining Flow's guarantees. This makes channel flow ideal for scenarios where work happens in parallel or outside the collecting coroutine. Callback flow is similar to channel flow but tailored for callback-based APIs. It lets you receive values from listeners or other callback mechanisms and emit them as flow. Like channel flow, it uses a channel to buffer values and deliver them safely to the collector. This makes it perfect for integrating legacy code or libraries that rely on callbacks. When you use channel flow, you can launch multiple coroutines inside the builder. Each coroutine can send values to the channel, and the channel delivers them to the collector in a thread-safe way. This approach allows you to perform parallel work and emit results without violating Flow's rules. The channel acts as a bridge, ensuring safe delivery. Callback flow lets you register listeners or callbacks and emit values as flow. When a callback is triggered, you send the value to the channel inside callback flow. The channel then delivers the value to the collector, maintaining Flow's execution guarantees. This makes it easy to adapt existing callback-based code to work with Flow. Imagine you need to perform several tasks in parallel and emit their results as flow. With a regular flow builder, this isn't possible due to the emission constraint. But with channel flow, you can launch multiple coroutines, each sending results to the channel. The collector receives all values safely, and your code remains clean and efficient. Suppose you're working with a legacy API that delivers results through callbacks. With callback flow, you can register the callback and send values to the channel whenever the callback is triggered. The collector receives these values as flow, making it easy to integrate old code with modern coroutine-based architectures. Both channel flow and callback flow maintain Flow's execution guarantees. They ensure that values are delivered to the collector in a thread-safe, predictable manner. This prevents race conditions, inconsistent state, and unsafe UI updates. By using these builders, you can confidently handle values from any source. Let's recap the main points. Flow runs both the flow block and the collector in the coroutine that called collect. Emit must be called from that same coroutine, or Flow throws an error. This limitation appears in real projects when values come from callbacks, legacy code, or external sources. Channel flow and callback flow solve this problem by providing a structured way to receive values from any context. Use channel flow when you need to handle values from multiple coroutines or perform parallel work. It's ideal for scenarios where emissions come from different contexts, and you want to maintain Flow's safety guarantees. Channel flow gives you the flexibility to scale your data streams without sacrificing reliability. Callback flow is your go-to builder for integrating callback-based APIs or legacy code. It lets you receive values from listeners and emit them as flow, making it easy to modernize old codebases. If you're dealing with external events or APIs that don't use coroutines, callback flow is the perfect solution. A common mistake is trying to emit values from multiple coroutines in a regular flow builder. This leads to errors and unpredictable behavior. Always use channel flow or callback flow when dealing with parallel work or external sources. These builders are designed to handle such scenarios safely and efficiently. When working with Flow, always consider where your values are coming from. If they originate from the collecting coroutine, a regular flow builder is fine. If not, switch to channel flow or callback flow. This simple rule helps you avoid errors and keeps your codebase robust and maintainable. In a real Android project, you might need to expose events from a third-party library as flow. If the library uses callbacks, you can wrap them with callback flow. Register the listener, send values to the channel, and clean up when the flow is closed. This approach keeps your architecture clean and leverages Flow's power. Legacy code often starts work in GlobalScope or on unmanaged threads. With channel flow or callback flow, you can safely receive values from these sources and emit them as flow. This makes it easier to modernize old codebases and integrate them with new coroutine-based components. External components might return a disposable or require explicit cleanup. With callback flow, you can manage these resources by registering the callback and cleaning up when the flow is closed. This ensures that your app remains efficient and free of resource leaks. To sum up, Flow's main limitation is that emit must be called from the collecting coroutine. This keeps things simple and safe, but restricts what you can do with external or parallel sources. Recognizing this limitation is the first step toward building more flexible and robust data streams. Channel flow and callback flow are designed to overcome Flow's emission constraint. They provide a structured way to receive values from any context, ensuring that your data streams remain safe and predictable. By using these builders, you can handle complex scenarios with ease. This video focused on Flow's limitation and why regular Flow builders can't handle certain scenarios. In the next part of this series, we'll introduce a simplified version of channel flow and explain how both channel flow and callback flow work internally. Stay tuned for practical examples and deeper insights. If you found this breakdown useful, consider exploring more about Kotlin flow, channel flow, and callback flow. There are many resources and articles that dive deeper into these topics, offering practical tips and real-world examples. Expanding your knowledge will help you write better, more reliable Android apps. This series is brought to you by Anatoly Frolov, a senior Android developer with a passion for honest, real-world Kotlin and Jetpack compose insights. With years of experience and a knack for clear explanations, Anatoly helps developers navigate the complexities of modern Android development. Kotlin Flow is a powerful tool for managing asynchronous data streams in Android apps. By understanding its limitations and the solutions provided by channel flow and callback flow, you can build more robust, maintainable, and scalable applications. Always choose the right builder for your use case. For more on Kotlin Flow, check out articles like 9 Kotlin Flow Mistakes You're Probably Making and the Real Difference Between With Context and Launch. These resources offer practical advice and help you avoid common pitfalls in coroutine-based development. The Android development community is full of professionals sharing their experiences with Kotlin Flow, channel flow, and callback flow. Engaging with these discussions can provide valuable insights and help you stay up to date with best practices and new techniques. To wrap up, remember that Flow is great for simple, in-context data streams. When you need to handle values from multiple coroutines, callbacks, or external sources, switch to channel flow or callback flow. These builders ensure your code remains safe, efficient, and easy to maintain. Let's quickly visualize what we've learned. Flow works best when everything happens in one coroutine. Channel flow and callback flow act as bridges, allowing safe emissions from multiple sources. This visual model helps reinforce when to use each builder for your data streams. In the next part of this series, we'll look at more practical examples that rely on callback flow. These real-world scenarios will show you how to apply what you've learned and solve common challenges in Android development. Callback flow appears most often in real projects, especially when integrating with external APIs or legacy systems. By mastering callback flow, you'll be able to handle a wide range of scenarios and keep your codebase modern and efficient. Beyond channel flow and callback flow, there are many advanced topics in Kotlin Flow and coroutines. Exploring these will deepen your understanding and help you tackle even more complex challenges in Android development. The world of Android development evolves quickly. Stay updated by following experts, reading newsletters like Android Weekly, and engaging with the community. Continuous learning is key to mastering tools like Flow, channel flow, and callback flow. Thank you for joining this deep dive into Kotlin Flow, channel flow, and callback flow. We hope you now understand why these builders matter and how to use them effectively. Keep experimenting, keep learning, and happy coding. Ready to take your Kotlin Flow skills to the next level? Explore more about coroutine builders, structured concurrency, and advanced flow operators. The more you practice, the more confident you'll become in building responsive, robust Android apps.